What's going on, you guys? Mr. Allen here, working with a couple polynomial functions and their graphs in this video, and we are tasked with writing p of x in factored form across a set of real numbers. So some directions will state across a set of complex numbers, and you need to bring imaginary numbers and whatnot into it. For this one, we're keeping it real. All right? Now I'm going to start over here with this one, this p of x and its graph. How do we address the situation? Well, if I look at my x-intercepts here, I know this one's definitely at positive 4, 0. These are a little hard to tell on that graph. It's somewhere between 0 and negative 1, so negative a half, negative 1/3, I don't know, and somewhere between negative 2 and negative 3. So I don't know for sure what it's going to be, so I can't really write my factors. I know one of my factors will be x minus 4, right? I know that for sure. But how do I get the other two? Well, if I know one of my zeros, one of my factors, I can divide this factor out of this polynomial, right? This factor is going to be x minus 4. That's what I'm going to see in my function, right? So I can divide that out of this cubic, which would leave me with a quadratic, which hopefully, fingers crossed, I can factor, all right? So let's do a little synthetic division here and see what we can work with. So I'm going to set up the synthetic division. 4 is going to be chilling up here. Then I got 6, negative 7, negative 63, and negative 20. You can also do this with long division, but why, right? Synthetic division, much cleaner, easier. Love it, right? So we'll drop the 6. 4 times 6 is going to be 24. Add these, I've got, let's see here, oh my gosh, 17, right? I don't want to make a mistake here. And then I have 4 times 17, that is 68. Add them, I get 5, multiply 20, remainder 0, excellent. So in this situation, if 4, 0 is an x-intercept, my remainder has to be 0, or I did something wrong, or I counted wrong, right? Or the problem's wrong. Probably not. Maybe if I made it, who knows, if I didn't key it yet. But my remainder has to be 0 because this is a 0. This is a factor. It should divide out nicely without a remainder, okay? So red flag if that's not 0. Now, we know that this is going to be a remainder, our constant, x and x squared. So let's write it out, okay? 6x squared plus 17x plus 5. And if I want to find, I want to just write it in factored form, right? Let's just factor this thing. I don't even need to set it equal to 0. I just want to factor it, right? I'm not asked to find my x-intercepts. If I was asked to, I would set them equal to 0. But for now, I just need to factor this. And I'm a big fan of guess and check. But if that's a little out of your league or you don't like to do that, feel free to do rainbow method. Here's how I'm going to go about it. There's only one way to get 5, right? It's with 1 and 5. I also know that this is positive and this is positive. So everything has to be positive here if it's going to work out. So that takes some of the guesswork out of it. My only other question is what to do with the 6x squared. Well, there's a couple ways to get 6x squared. Let me jot down a little side math. I can have 6x times 1x, or I can have 3x and I can have 2x, okay? Hopefully that's stuck on the board there. It is, okay. So I can place either these two here or here. I can flip-flop them, or I can put these two here or here. I usually start with the two that are closest together, okay? Then I work my way out, okay? There's not necessarily like, it's always that, or more commonly that. It's just a systematic approach. So I put 3x and 2x here. 3x times 5 is going to be 15x. 2x times 1 is 2x. That has a 17x. Ayo, first try. Cool. So sometimes when I guess and check, I actually work like I start with these two if it's a prime number because I know it has to be that. And then I'll work with my lead guy. Even though usually we start with the lead guy, I found that to be maybe a little bit easier. Up to you though, okay? It's all about guessing and checking and being somewhat systematic about your approach. So we're good to go here. I've got 6x squared. I've got 1 times 5 is 5. We have 15x. 2x adds to 17x. Good to go. All right. So those are my two factors along with this guy here. Let's write our final answer. And I'll put that in a different color orange so it pops. The math's got to pop. P of x, whoa, it's crazy x, is we would have x minus 4. Don't forget that one. People often forget that. 3x plus 1. And 2x plus 5. Boom, factored form right there. Now, if we wanted the x-intercepts, I'll write them down even though this wasn't part of the problem if they wanted the x-intercepts here for this one because it can definitely happen where we ask you for those, especially when they're all reals. Over here, we got a couple of imaginaries that are going to happen. I'll tell you why later. So we would have negative 1/3, right? Negative 1/3, comma 0. If I set that equal to 0, I'd subtract 1, divide by 3. I'd have negative 5 over 2, whoops, comma 0. And then I would have 4, comma 0. So if we asked for the x-intercepts, you can put them right there. I didn't ask for them in this one, but now you're ready just in case you are asked. All right. Questions? Okay, cool. We can move on. We can move on. That joke will never get old for me here while I'm in my garage on my own making these math videos for the people of the internet. All right. Making sure I'm still recording. We're good. Next one. P of x. How did I know there was going to be a couple imaginaries? Well, this is a cubic function based on its shape, at least, maybe a degree of 5. It also says right here that it's a cubic function. And I only have one x-intercept that I can see. So the other two are imaginary. Remember, all imaginary solutions come in pairs. 2, 4, 6, whatever. Okay, there's either 0 of them or there's an even number of them. So same kind of idea here. I'm going to use what I know, which is the negative 3 right there, negative 3 comma 0. My factor would be x plus 3 in this case that I'll use in a little bit. But I'm going to divide out this factor x plus 3 from a cubic function, leaving me with a quadratic function, and then we'll see where we go from there. Okay. So let's do that. Synthetic division. Once again, for the win. Negative 3 goes up here because it's what x equals. It's what makes it 0. There we go. It's a better 3. 1, 5, 9, and 9. We'll go ahead and drop this 1 and get started. Get the synthetic division party started. Negative 3 times 1. Negative 3. 5 plus negative 3 is 2. Then we multiply. We get negative 6. Add. We get 3. Multiply negative 9. Remainder is 0 as expected, as we had hoped. And I have, let me do that in the same color scheme here. Remainder, constant, x squared. That makes sense. I divided out a linear factor from a cubic function, left with a quadratic, okay? Kind of internalize or think about those things about why this becomes that. After I divide out that, it'll help you conceptualize. It'll help you understand this bigger picture of things going on rather than just memorizing random steps, okay? Easy to get lost in the mathematical sauce if you're just memorizing steps. So now I have x squared, 1x squared, plus 2x plus 3. Now, can we factor that? Does anything multiply to 3 while adding to 2? No. If this is negative 3, we got it, right? You could do 3 and 1. One of them and then negative 1. 1 being the negative. But we don't have that luxury here, right? This is not factorable. So if I wanted, I could factor it across a set of imaginary numbers using the quadratic formula and other awful things, and it'd be terrible. It'd be terrible. So no, we're not going to do that. We're going to get our final answer here. P of x equals x plus 3, x squared plus 2x plus 3. That is it. Cool? That is my factored form. Now, if we ask for x-intercepts in this one, this is one of them. You'd actually have to do quadratic formula for that. I'm not going to get into that here. You could do it, right? Opposite of b plus or minus square root of b squared minus 4ac all over 2a. But perhaps in another video, because I think this is enough here. We've got it in factored form across the set of real numbers. That's dope and awesome. If you guys have any questions, ask me in the halls if you go to school where I teach, or pop it in the comments. Spread the word, like the video, subscribe, and stay awesome.